new direction for our class. To help us understand this new direction, I'll take a moment to look back at where we've been so far this semester and where we're headed. Then we'll move on to understand some of the fundamentals of data. Recall that our definition of sustainability is the ability of a social, economic, or ecological system to meet the needs of the present generation without compromising the ability of future generations to meet their own needs. At the heart of this definition is the idea of systems, and this has been the focus of our work so far this semester. In order to quantify aspects of systems, we started the semester by considering the fundamental issue of measurement. We then introduced stock flow models as our fundamental tool for modeling and understanding systems. Over the course of the semester, we have developed the important ideas of equilibria, feedback loops, and tipping points. We also examined some concrete models, the exponential and logistic models, that allowed us to describe systems more precisely under the right circumstances. As we move forward in the course, we'll pivot to new ideas that help us understand risk and help us make decisions. Chapter 5 will touch on ideas from statistics and probability. This is a big topic, so we'll focus on fundamental statistical ideas that are key to understanding data, as well as a few probability ideas that address uncertainty and risk in the context of sustainability. In our Chapter 6 work, we'll examine theories that provide economic, political, and ethical perspectives on making decisions and how they relate to sustainability issues. To begin this new direction, we'll talk through some fundamental ideas related to making sense of data. Let's start at the very beginning. What is data? In general, data are characteristics or information collected through observation. For a set of data, we want to keep in mind two aspects: the individuals or cases, which are the people, objects, or entities being described by the data, and the variables, which are each characteristic or kind of information collected about individuals. If you view raw data in a table, each individual often takes up a different row, whereas each variable is represented in a different column. Identifying the individuals and variables for a data set are an important first step in understanding what conclusions can be drawn. Let's apply these ideas to an example. Here, I've shown 1999 data from the annual Christmas bird count organized by the Cornell Lab of Ornithology. These counts were reported from sites across Texas. The sites are the individuals for this data. The information being reported about each individual site is the number of species being counted. This is the variable for the data. The bird count might also be interested in what species were seen at each site, or if a particular species was seen there. That would represent additional variables for the data. The following graph was taken from a 2017 New York Times article on DACA recipients. DACA stands for the Deferred Action for Childhood Arrivals program and refers to the U.S. immigration policy that allows undocumented immigrants who arrive to the U.S. as children to receive deferred action from deportation, as well as a work permit. The graphs presented here show a summary of the original data rather than the raw data. Teasing apart the summary graphs, we can identify the individuals as individual DACA recipients. The variables recorded for each individual are the current state of residence, summarized in the left graph, and the age of entry, summarized in the right graph. In order to make data meaningful, we often have to summarize it in some way. This allows us to look for general patterns as well as identify exceptional data points. The way in which we summarize data depends on what type of variables have been collected. A categorical variable assigns the individuals to categories, whereas a numerical or quantitative variable measures something about each individual. Recall that a key aspect of measurement is units. In general, a numerical value should have a unit associated with it. Recall that the variable reported for the bird count data is the number of species counted. This is a numerical variable. The units here are simply species. For the DACA data, we have two different variables. The first categorizes each DACA recipient by the state they currently reside in. This is a categorical variable. The second variable measures the DACA recipient's age at entry. This variable is numerical. And the units here are years.